Hello class, today I'm going to be talking to you about elasticity. This is going to be the introduction, the first in a series of lectures about this topic. So what I want you to get from these series of lectures, my learning objectives for you in this unit in our course. The first is just getting to know the definitions. I want you to be able to define elasticity, particularly the terms what it means to be elastic versus inelastic. We'll talk about different types of elasticity, price elasticity of demand versus price elasticity of supply, and we'll talk also about income elasticity and cross-price elasticity. I also want you to learn how to actually numerically calculate price elasticities. We'll do this using information from demand and supply curves. We'll use this for graphical representations. We'll use this in terms of equations. I also want you to be able to do this just looking at different points. And then finally, doing calculations with elasticity, we'll also look at how, in particular, the price elasticity of demand relates to total revenue. And then the final learning objective for this unit is that I want you to be able to know and name and understand the determinants of both the price elasticity of demand and the price elasticity of supply. In terms of the lectures, the outline, what I'm going to do in this first lecture is mainly be focused on the definition of elasticity, what it means both practically and mathematically. Then we'll talk about how to calculate it, and different ways to do that. I'll then introduce different terms around elasticity and what they mean before moving into a mini lecture on the determinants in terms of what makes a particular good or category of goods more or less elastic. And then finally, we'll close with talking about how it relates to total revenue. So continuing on into this unit, where we are mainly focused on the definitions. The first question is, what is elasticity? Elasticity at its heart is a measure of responsiveness. You have an action, and then there is some level of reaction. You can kind of let your brain think about a rubber band. The action is you're stretching it out. The reaction is releasing it. It comes back together. If you're pointing at someone, it might go flying. Rubber bands are elastic. They react. Some examples might be how do final exam scores respond and react to increase in study hours? How does your 5K race time react to the number of days and time you spend training? How does voting react to campaign ads? Elasticity, though, we're going to see going to be different than other measures of responsiveness and useful for a specific purpose, because elasticity is not going to be connected to units. So all of these examples that we are talking about here might be hard to sort of compare in terms of the reaction that we're getting from these different stimuli. Voting, very different from exam scores, very different from race times. But we can speak to the responsiveness by looking at elasticity. Because it's unitless, it allows us to make comparisons across different actions, reactions, and for our application in economics, it's going to let us do comparisons across different markets and different goods. Elasticity is a mathematical concept, so I also want to define it mathematically. We'll generally in this class be using this symbol, the lowercase Greek letter epsilon. However, epsilon is a very popular Greek symbol, very in demand, if you will. So occasionally you will see elasticity represented as the Greek letter eta. It looks like an N, but it's eta, so also kind of starts with an E, and so that's why it's used for elasticity. So mathematically, elasticity, again, we're thinking about this response and an action. So it's not just response divided by action, similar to what we talk about in maybe a slope, but the response is going to be importantly measured in percent change. And so is the action. We're looking at a percent change in terms of the response divided by the percent change of the stimulus or the action. Generally, for what we're going to be talking about, the response is going to be a quantity, whether it's changes in demand or supply, and the action is going to be movements in price. So what we're generally going to be talking about in this course for elasticity, not always the case, but more often than not, is we're going to have a percent change in quantity divided by a percent change in price. So now let's move from the general definition of elasticity to a more specific definition of one type of elasticity, the price elasticity of demand. So we are often in economics interested in how price impacts demand, and in particular, to use the correct terminology, how price impacts quantity demanded. Now this information we already have introduced in our previous unit in talking about the demand curve. The demand curve is capturing this relationship between price and quantity. And we've also seen this relationship represented in a linear function where quantity demanded is some function of price. And we can already talk about some level of responsiveness without knowing elasticity. We have. For instance, we can talk about what the impact of a $1 increase in price will be. Using this linear demand curve, hopefully you remember the law of demand, which tells us that an increase in price leads to a decrease in quantity demanded. And we also know that that $1 increase, because we have the slope of 2, the coefficient of -2 here, that $1 increase in price is going to decrease quantity demanded by 2. So we already know something about responsiveness through the demand curve, but what we're going to be doing with elasticity is trying to make more sense of this relationship in terms of understanding, is the $1 change big or small? Is the 2-unit change a big or small response? And what we're going to want to be able to do is make comparisons across goods and across markets. In essence, be able to compare an apple market to an orange market and talk about which is responding more or more sensitive to price changes, or the term we're introducing here, more elastic. So let's look at another demand curve. Here it's set up differently, but if we're looking at a $1 increase in price, again, we always have, when we're talking about demand, a decrease in quantity demanded with price, and again you can see this slope of -2. And so in this particular instance, it's going to decrease quantity demanded by -2, or decrease it by 2. So in terms of units, in terms of the change in quantity demanded, it's the same. But is this impact the same? And to be able to understand and know that, we actually need more information about our market. Let's give these two demand curves. Let's say the first one is the number of pens sold here in the college bookstore. And when we're talking about a $1 increase in price, we're moving from $1 to $2. Right? And so and let's say with that demand curve, we're moving, then we could do that calculation and see that quantity would change from $8 to 8 pens to 6 pens with that change in price. Now for the second good, let's define it as the number of computers sold in Newton County. Now we've emphasized that we kind of need 3 things to properly define a market. We need the good, we need the location, and we need the time frame. And I said we're often going to glaze over that last one especially, but often that second one. But we are giving you the geography here. But now let's say that $1 increase for computers in Newton County is moving it from 500 to 501. So it's in terms of relative terms a much smaller price change. And let's use pick some numbers here. If we're doing our calculations, we can see that the quantity demanded will change from 500 to 498. All right, let's do the kind of calculation here and show you how it gives us an idea of making a comparison between pens at the bookstore and computers in Newton County, and gives us an idea of the differences in those goods that allows us to make a comparison between the responsiveness of those. So we're going to look at the size of the price change, and we're going to look at these as a percent. Right? So in both circumstances we had a $1 increase, but they were very different in terms of what the baseline was. So as a percentage change in price, that triangle looking thing is a capital delta. We'll use that often to be a shortcut for change. So that notation there says percentage change in price. And the percentage change in price for the pens at the bookstore was a full 100%. It was a 100% increase. It doubled in price. Now, for computers in Newton County, that $1 increase was barely anything because the baseline price was $500. So that dollar change in price was less than 1%. It was 1/5 of 1%, or 0.2%. Now let's look at the size of the quantity response, again looking at it as a percent change. So we had a drop in 2 pens at the bookstore. So we have a -2 there for the change in quantity, and our baseline, our starting quantity was 8. So as a percent, we have a drop of 25%, or -25%. For the computers in Newton County, there was also a drop in the quantity of 2, but the baseline was much larger. The baseline was 500. So again, we're less than 1%. It's a drop of 0.4% for computers in Newton County. Now, doing these intermediate calculations now allows us to move and talk about elasticity as the measure of responsiveness, and allows us to say something about how responsive pens and computers are comparatively. And if you remember from our formula, the formula for elasticity is the change in the response variable. This is quantity expressed as a percentage, so the percentage change in quantity divided by the percentage change in price. In this case, for pens, the percentage change in quantity is 25%, and the percentage change in price is 100%. And so the elasticity, the price elasticity of demand for pens is -0.25. Just a note about signs here. In general, for elasticity, we care about the sign because we care if the stimulus is impacting the outcome variable positively or negatively. But with demand, we know that the law of demand tells us that it's always going to be negative. So we often get sloppy when we're talking about price elasticities of demand and simply discuss them in absolute value terms. So generally speaking, we are going to care about the sign, but for elasticities of demand, we get a little sloppy as economists. Just giving you a heads up there. So let's look at that same measure, elasticity, for computers in Newton County. Here we had the percent change in quantity was 0.4%, and the percent change in price was 0.2%. So our elasticity here is -2. And we can see what this is actually telling us is that in terms of responsiveness, the computers in Newton County were actually more responsive to the change in price than the pens. Now, we had to do these calculations to be able to figure that out. It might have been hard to just kind of look at the demand curve or kind of look at the fact that we had those -2 changes for both without doing the work of calculating elasticity. So that's what elasticity is made for. That's what elasticity is giving us, is telling us the responsiveness in a unitless comparison. And that's the end of this first unit about defining what elasticity is. Next up, in our next video, we're going to be covering, and hopefully you're going to be learning, different ways to calculate elasticity. So hopefully you'll be able to join me and tune in there. Always email me if you have questions, and have a great day. Bye.